So hopefully this new session is as interesting as the previous one. So far we have looked at domain-specific problems and how analytics has solved them, right? But what are the analytics-centric approaches, or what are the analytics-focused techniques that we have developed to solve some of these problems, right? Some of these challenges that we spoke about: complexity, scale, right? Speed. What have we done, right? So the first, another reason for discussing this is I have always hoped that whatever gets discussed in a course session is Googled sometime. I want participants of this session to Google these terms and know more about this, right? These are very valid domains now, right? The first such domain is financial engineering, right? This term itself has been coined. So financial engineering is supposed to be at the intersection of mathematics, computer science, statistics, data science, and economics, right? So it's the combination of all this. This is essentially engineering financial decisions. That's the way to describe it, and that's why the term has come, right? There are other terms that are very commonly used. For example, mathematical finance or math finance, right? Or computational finance. Now the way these terms are being used, usually it is said that mathematical finance as well as computational finance have been now more or less classified as subdomains of this financial engineering, right? We have to be clear here. We are not talking about a new engineering domain. We are not creating a new mechanical engineering, civil engineering kind of a thing. So this is not to be confused with a typical traditional domain. However, having said that, a lot of current practitioners and current students of financial engineering have come from traditional engineering domain, right? And once again, people have blamed this kind of development. People have, for example, during the 2007-2008 financial meltdown, people have blamed that a lot of these physics PhDs who knew a lot of mathematics came to finance, and therefore they developed financial products that nobody understood, right? This has actually attracted some criticism. Whether that criticism is justified or not, that's not the judgment call that we are taking. But a lot of the practitioners of financial engineering have traditionally come from engineering domains, right? Math domain, data science domain, computer science domain, right? So it has happened. But we are not talking about engineering field per se. We are not talking about engineering field. As I said earlier, the best way to understand financial engineering is to say that we are trying to engineer financial decisions, right? Now this term is referred to in a very negative connotation, quants, right? They are called quants. This is a short form for quantitative analysts, right? So this is a person who typically works in finance, but applies a lot of quantitative techniques, right? May or may not have a formal degree in finance. As I was saying, PhD physics destroying finance, right? Quote unquote. This is not my quote, right? So I need to put that very clear. Quants have been praised, quants have been criticized. This is not a judgment call on them. We are only saying that quants are a reality. Quants exist in the market. They have contributed to the development of financial innovations. Right, and as with any innovation, that innovation may be used for good, may be used for financial meltdowns, right? So quants are a reality. Quants are people who have significant quantitative skills, and they have chosen to apply those quantitative skills to the domain of finance, right? So they are practitioners of financial engineering. And now actually this is a very specialized field. Very reputed Ivy League universities actually have a master's degree program in financial engineering, right? So if you want to explore this domain further, yes, you know where to go now. So you can actually get a master's after your BSc degree from IIT Madras. Look for that. Very interesting, very practical, very useful field. Combines skills of mathematics, statistics, data science, and then applies to finance. has proved to be very useful, has helped the market quite a lot, right? And a lot of innovations have come out of applications of this financial engineering, right? So new domain that was created because significant analytic skills existed, significant applications existed in finance. Therefore, it was a very natural for these quants to apply these skills to finance, right? So that's the way I look at this. Okay. The next thing that we have coined is very similar on the same lines. Now we are talking about something called marketing engineering, right? You see the similarity. So engineering marketing decisions, right? That's so this term itself came in the last part of the last century, 99-98 types. Yeah. So this, I have it here. The term itself came from this article called Age of Marketing Engineering, right? Professor Lillian is a very well respected professor of marketing, right? And along with two of his co-authors, he coined the term marketing engineering. So according to them, what is marketing engineering? Marketing engineering is I am quoting directly from the article. So using computer decision models for making marketing decisions, right? Using computer decision models to make marketing decisions. Once again, emphasizes the point that we have been making throughout. Analytics, the purpose of analytics is to take decisions, good decisions. Here we are talking about making marketing decisions, taking marketing decisions. So essentially decision models, very automated, very sophisticated decision models which have to be run on computer. They helping us taking marketing decisions is essentially marketing engineering, right? Another definition from a different source. I will give you a minute to read through this definition. I have highlighted the important points in that definition anyways. So this is a systematic approach which uses data, right? So this is a data-driven approach.
Sir,
so yes, Swami?
Sir, may I make a point? One interesting application of this marketing engineering is the customer segmentation. We also saw this in the previous marketing analytics slide.
Yeah.
For example, let us take telecommunication industry, Airtel, Vodafone, Jio. So 10 years back, we all had one single plan. For companies used to give one particular plan for all the customers. So right now they have different segments. For example, there is a family plan. There is unlimited talk time between the family members. And then there is some people use network only for watching movies and watching cricket. Yeah, so there is a separate plan for them. And then there are a particular type of people like delivery executives from Swiggy, Zomato, and then there are these cab drivers who make a lot of calls, but the duration is very short. So right now, the telecommunication companies, they are segmenting customers and then they are sending individual promotional schemes for these particular segments. So that's a very interesting application of marketing engineering in the telecommunication industry.
Very, very true. Very true. In fact, let me share a personal anecdote. I am a PhD in OR. Immediately after my PhD, I was actually offered a job with a telecom operator in US. And apparently my job was supposed to be coming up with these pricing mechanisms for these plans. So I mean, this was in 2006. So telecom operators were very sensitive to the importance of these analytical tools. So I was supposed to be the OR engineer in their pricing team, right? Pricing is it's a marketing sales driven function. So they had a team, and I was not supposed to be the first one there. They had a team there, and my job was supposed to run OR models to help them price their plans, various plans better. And probably if I had joined, probably they would have asked me to come up with new plans, right? So yes, completely agree with you. And the applications are just endless now, right? I mean, the kind of things that you can do once you have these very sophisticated data-driven techniques, optimization techniques, or data science techniques. So I mean, what you can do with better understanding the customers, providing them what they would want, right, is just I mean, just amazing the kind of thing that you can offer.
Very true, sir.
In fact, we have discussed, so let me quote another article from the same classic article which created the term marketing engineering. So they actually argue that, what Malolan was asking earlier, do you need business knowledge, right? So their argument is they have taken a stand, right? Not something that we have discussed earlier, but according to this group of people, apparently you don't need marketing skills at all. They say as long as you can read from databases, you are good enough. Go ahead, do it, right? That's their point of view, but that tells you, right? That tells you the power of analytics. They say, well, no marketing needed, right? Same argument. 2 slides ago, we were talking about PhD physics. Now we are talking about database engineers taking marketing decisions. Sure, why not, right? Going back to our 2x2 matrix earlier, as long as good analytics leads to good decision, it should not really matter who is taking those decisions, right? So, in fact, in our course also we have tried to do something, right? We have looked at conjoint analysis, which is kind of a choice modeling. There are lots of things, right? There is something called this CLV, right? Customer lifetime value, which looks at what is the value that this customer is deriving throughout his or her lifetime, right? So what's the customer worth to me, right? So that's essentially CLV. Amazing set of tools. Sorry.
Yeah. Yes, sir. After you finish, I'll just come back.
No, go ahead. So
yeah. So in fact, that's something very interesting. While marketing financial products, what they actually do is they check whether the person is let's say you're offered a credit card. What they actually check is not your ability to pay the bill, but your ability to pay the bill after the due date, because that is when they generate the revenue.
Yes.
Right.
Yes.
So that is a marketing decision and the financial decision for my product. So I don't even have to know about anything about you, just about what is your payment pattern, and then I will say whether this guy has to get be given an offer of credit card or not, or should I give him offers to retain him in my business because he is profitable to me.
Yes.
So it's purely data driven, like the statement says. This decision is for a marketing domain, for a financial product, based on your financial data.
Correct.
Which brings us back to the initial point. Know what data you need for what problem.
True. I mean, see, yes, even in the finance domain itself, right? There are 2 kinds of traders in the market, right? People who look at investment decisions by looking at the organization. This organization is in this industry. This industry is doing well. This organization has all these skills. They have good set of managers, and therefore I would invest in this company, right? They look at all this. There are some people in the market who simply look at the time series, right? They look at the time series of the stock prices in the last 3 months, right? They look at the fluctuations. They do amazing mathematics. And essentially, I don't care what the company is. I don't care what the industry is. I don't care who the CEO is. My job is to only look at whether this time series will go up or go down in the next 7 days or 3 days or 4 hours, right? And invest on that. Don't worry about the company, right? I don't need to know about the company. I don't need to know the business. But can I still make money from this investment? Right. So they are the pure data scientists, I would say. Right? I don't care what industry you are in. I don't care whether the CEO is going to get arrested in the next 7 months. I don't care. I only look at the time series, right? I only look at the time series using really amazing forecasting powers. I will only have to say whether this stock is going to go up in 4 hours. Going to go up, invest now, sell in 4 hours. Right. So, I mean, there are all kinds of people, and once again, the point is the same. I can take those decisions if I have analytical capability. And we are not making a judgment call that this is a wrong thing to do. I'm not saying, right? I mean, you are in the stock market. Your objective should be to make money. Whether you make money looking at the industry, looking at the company, looking at the CEO, or you make money simply by looking at the time series, is your decision, not mine. My argument is
always the same.
Sorry?
The objective has always been the same.
Objective has always been the same.
The method that we use is different, yeah.
Yes.
We should
yes.
process it different, yes.
Okay. Even in marketing, right? Operational excellence, right? Operational excellence has been driven by analytics, right? Essentially, operational excellence is defined as execution of strategy, most efficient execution of strategy, right? So operations people often don't get to design strategy, but they are the people who are asked always to execute the strategy. And how effectively can you do it tells you how effective the operations manager is. Essentially that has been done through the typical analytical cycle, right? Collect operational data, define performance metrics, build your models, get recommendations from that model and implement so that your effectiveness or efficiency increases. You get your desired output on your performance matrix, right? That has always been the algorithm. These steps have not changed, right? So what models you use are essentially different now. We are using more data-driven models. Even Industry 4.0, right, which according to me is some kind of a data-driven decision engine. And not only decision engine, it actually automates the decision, right? For example, I mean, a simple extension of what we were discussing earlier. If I have put correct sensors on a particular machine, and if the sensors detect that machine is going to fail, now Industry 4.0 says that, well, why are you waiting for the human intervention? Stop the machine. Stop the machine, get the predictive or prescriptive maintenance started on that machine. Don't wait, right? Don't wait. Earlier, maintenance used to be essentially accident driven. Once the machine fails, I will maintain it. Then we said, no. Every 3 months we will have a maintenance activity on that. Now we have reached a stage where we are collecting data every minute, so I don't have to wait for the 3 months to be over for me to know that the machine is failing. Right? Machine may fail even before that. Machine may not fail at the end of 3 months. So why am I performing this maintenance every 3 months? So now Industry 4.0 says that, well, sensorize, essentially put sensors everywhere, monitor the condition of the machine minute by minute, and take decisions whether to take the machine for maintenance based on the data that you are getting, right? And now we are, I mean, so far we have not spoken about it in this course at all, but the design of these sensors now tells us that data can be in any format. Data can be videos, data can be pictures, data can be actually numbers, and then I have to worry about how to convert those videos into numbers, right? So now I can take decisions based on any input data, right? But essentially, the whole operational excellence is getting driven through automation and essentially very clever use of sensors, which is what Industry 4.0 is, right? You can talk about various applications, right? Quality measurements, for example. Quality measurements have been completely data driven now. This whole idea of Six Sigma is completely data driven, right? Supply chain efficiency, once again, how do I measure efficiency, effectiveness, availability of a supply chain? Monitor data across the supply chain. Now I have capability. Because I know where my truck is now, right? I exactly know where my truck is. I exactly know how much time it is going to take. I exactly know when the truck fails on the road. I know everything. Therefore, I can manage supply chains, as Gemini was saying earlier, sitting anywhere, and manage it quite effectively. Now, yeah, I mean, so much research now has been done, so much progress has now been made that now supply chain analytics is a domain in itself, right? It is not even operational excellence. Now, supply chain analytics is a separate domain, and there are experts there.
A beautiful example for this would be our Swiggy, sir. If we place an order, it immediately shows you the nearby, let's say, people who can pick it up, where they are going, whether they have gone there, or in fact, due to the COVID, they are also giving you a temperature check of the person. Then when he is starting from there, when he will reach you. So we are actually seeing this operations excellence is now being thrown to the customer to see that they are also good. They are able to feel it. So that's a beautiful example that all of us are now feeling.
Correct.
Analytics in supply chain.
Yeah, even getting the customer participate in the whole process, right? I mean, that's the whole point.
Yeah.
So customer is actually tracking as much as the manager is tracking, even the customer is tracking the whole operations. So yes, and it has all been made possible because of very efficient use of data science, right? All the analytical skills. Okay, possibly, yeah, I mean, this is something that is very new, right? This is a textbook. This is a textbook called Operations Forensics. Richard Lai, the textbook came out in 2013. The argument is the following. You can look at the financial health of an organization by looking at the financial statements, balance sheets and profit loss statements and so on. How do you analyze the operational health of an organization? How do you do a operations forensics of an organization? So this textbook talks about that, and I strongly encourage all of you to look at this textbook. But the point is, I'm making this, I'm having this bullet point here because he argues that this would not be possible if you don't have data. This would not be possible if you don't have analytical skills to monitor organizational capability, organizational health of an organization. And this textbook then describes various techniques, various methods that can help you track operational health of an organization. So yeah, so all this is, once again, the point is the same. All this is possible because analytical skills, because of algorithms, because of availability of data. Nothing of this would not be possible without data. So that's the argument. My last slide, again making the same point that decision making and analytics are together. Good analytics should drive good decision making, right? How does analytics help good decision making? So far we have only said it should lead good decision making. There are various V's of big data, right? I have listed 3, but I mean, I have in various sources, I have counted up to 10 V's of big data. Let me focus on these 3 V's, volume, variety, and velocity. Today's world, we have already said, we are in the world of high volume, high variety, right? How does analytics help in better decision making? Because analytics can drive deeper insights faster, right? I can get much better insights and I can get them faster. That's the advantage of analytics. Will I not take the same decision, which is a good decision, without analytics? Yes. The problem is I will probably take longer time to reach there, or probably I may not reach that level of depth of understanding that I am able to reach with the help of analytics, right? So essentially, how does analytics help? Analytics helps because it can analyze a whole set of observations faster, right? So that can help me reach better insights. I am not taking decisions by small set of observations, right? I can look at various operating conditions and then take a decision. I can ask a lot of customers and then design a product. So this volume part, right? This variety part, I can ask a variety of customers and then design a product. So I'm taking decisions with wider consultation, with wider observations. Hopefully that can help me reach better decisions. And because of the speed of algorithms, right? If I use very efficient algorithm, if I use very correct algorithm, I can reach that decision faster. So that's my argument. My argument is analytics helps better decisions because it can operate at scale and it can operate at velocity, right? And considering all the uncertainties in the market, it can incorporate all these uncertainties in the model building process and therefore give me better decisions, better insights, and better insights hopefully give me better decisions, right? That's the argument. Okay. Traditional decision making processes would have, yeah, I mean, they would have reached the decision probably, but some time would have taken, right? Not at today's scale probably, but we are not, as again, we are not discounting our capability, our brain capability. But there is a machine that is able to do the same thing. So why worry about it? Let the machine take care of it, right? That's the whole point. Where do we go from here? completing the course now. This is my final slide. Where do we go from here? This was only an introductory course, right? We only brushed the surface of business analytics. Possibilities are endless, right? Depending on what you find interesting, what you find more important to you, what you find more applicable to you, you can take that direction. In terms of the BSc program itself, as I have said earlier, there are more management electives focused on analytics. They are coming, right? They are coming in your subsequent academic terms. Today, there are plenty of business cases that are available that explain how data was used to take decisions, right? If you can get access to those business cases, I strongly recommend that you read those business cases so that you can continue your learning even outside of this course, right? So plenty of examples where organizations have described how they use data, how they use analytics, how they use algorithms to take better decisions. And all these examples are well documented. Various cases are available, publicly available, right? So try and access them, right? So don't say that the course is over and therefore my learning should stop. But if you want to continue learning, there are more electives. But always remember that techniques are important. Data science, analytics is important, and the business problem that you are trying to solve is equally important. So yeah, with that, requesting all of you to share your final thoughts.
Yes, sir. The last point summarizes everything. We have taught them an introduction to different techniques. They have studied these different techniques during their mathematics courses, but now we are talking to them with a business context. In fact, that is how all of your lectures were actually around. So we first gave them the business context, or gave them the data, used a technique, then gave them the business context, or gave them business context, used a technique, and gave them the results. So that was the entire focus of it. And the emphasis was always on that business context. Understand the business context, because that gives you the ability to ask the right questions, which in turn gives you the ability to collect the right data and then proceed further. So I believe there is nothing more from my end, sir. Beautifully summarized. Thank you.
All right, then let us close this session also. So this will formally bring business analytics, the course, to a closure. Obviously, we will continue to interact. If you have any questions, any comments, any suggestions, reach out to me, and we will definitely have that discussion with you. Right? As a group, as a person, as an individual, doesn't matter. Right? So explore this beautiful domain of business analytics. And if you think that we all can be part of that journey with you, tag us along. We will be happy to be working with you and understanding from you. So with that, let us end the session here. Best wishes to all of you, and hopefully we meet somewhere, either in the e-world or in the physical world. Thank you. Best wishes.